Alright guys, so welcome to part 2 of this video. Looks like we're going to get into some maximizing and minimizing right now. Okay, so check it out. We have got this rectangle inscribed in a curve. When you guys have this, I want you to label X and Y. And I want you to say, and then that one's also X, that one's also Y. So, are we looking at area? Yeah, the area is base times height. Now, that's in two variables. I need to get this into a single variable, but we know that this equation is just this upside down parabola, negative x squared plus 12. So if I can replace that in here, my area is going to be 2x and then negative x squared plus 12. Okay? Which, by the way, if I want to think about the domain of this, if x is in a point in the first quadrant, it can go from 0 to where it's going to hit right there. Well, this is going to hit at square root 12. So it needs to be a number between 0 and square root 12, right? Okay, I don't want to do product rule. I'm not in the mood, so I'm going to distribute that out. That's my area. I'm not going to set that equal to 0 yet. I am going to take the derivative and get negative 6x squared plus 24. If I factor out a negative 6, I get x squared minus 4 is 0. So I have x plus 2, x minus 2. And so it looks like this will have a critical point at negative 2 or 2. Well, again, since I'm only dealing with the first quadrant, I'm just going to use 2. And my domain is between 0 and the square root of 12, which is bigger than 2. And I'm going to test this into my derivative, okay? Now, if I plug in 1 right here, negative 6 plus 24 is positive. If I plug in 3, let's say, 3 squared is 9 times negative 6 is negative 54. Anyway, that's going to be negative. And so this goes increasing, decreasing. So sure enough, it's going to maximize right here. And it's asking me for the maximum. So the dimensions to maximize it would be x equals 2. And then if x equals 2, I'm just going to go ahead and plug it in right here to get y, which is going to be negative 4 plus 12. So then y would be 8. So if we're at the point 2, 8, okay, that's going to maximize this. Oh, now the dimensions, oh, this is a little tricky. This point's a little particular, but I'll just look at the answers. The dimensions, well, because the bottom is 2 by 2, it's actually a 4 by 8, but like, it's fine. Okay. Let me do number 9 right here. We have two positive numbers. I'll call them A and B. The second is the reciprocal of the first. So that's what a reciprocal means, you guys. B is 1 over A. Find the two numbers so that the sum A plus B is a minimum. Okay? I should I could write that. All right. So I'm going to go ahead and say if B is 1 over A, then that's my sum. And my derivative is going to be 1. And then remember the derivative of 1 over A is negative 1a to the negative 2. And I need to set that equal to 0 to maximize it, okay? Well, first of all, a can't be 0. I could automatically get rid of that. And then if I bring this over here, so I'm going to solve this. 1 is 1 over a squared. So a squared equals 1, so a is 1. This is the dumbest problem I've ever seen in my life. Okay. If a is 1, this is my derivative. 0.5 squared is like, if I plug that in, I would get 0.25. 1 over 1/4 is 4, and 1 minus 4 is negative, and then positive. Okay? And so I end up getting on my sine line graph, boom, boom, right? And it wants the sum to be a minimum. Oh, I'm using A and B, not X and Y. A is 1, and if I plug it in right here, B is 1. Lame. Okay, Let's look at this rancher question. Okay, rancher plans to enclose 3 sides of rectangular pasture with the 4th side being against the rock. He has 1,200 yards of fencing. That's a perimeter thing, right? So my perimeter, which is 2x plus y, is 1,200. Okay, what's the maximum area he can enclose? Well, my area is just base times height because that's in 2 different variables. I'm going to go ahead and solve for this. Y is negative 2x plus 1,200. I'm going to plug that in there. So my area is x, and then negative 2x plus 1,200. I'll go ahead and distribute that. So it's going to be 2x squared plus 1,200x. So a prime is negative 4x plus 1,200. When I set that equal to 0, going too fast. Negative 1,200. X is 300. Okay. Again, I really got to do my sine line graphs here because if it asks me for like the wrong, like I don't want to just say, well, it's 300 and like be done, right? Now look, that side X, it can't be less than 0 and I only have 1,200 yards of fencing. I always try to think of the most extreme version. What if I had 1199 on that side, 1199 and like, oh no, it would be half of that, wouldn't it? It would be like 599 there and 599 there and like 2 there or something like that, right? That's the most extreme case. So X has to be between 0 and 600. Because if X was 600, it would take up all of the fencing. Okay, now when I test something into the derivative, say I test the number 1, I get a positive. Let's say I test 500, I get a negative. So this is maximizing, and I'm trying to maximize the area, so I'm good. So X is 300. If I plug it in right here, Y is negative 600 plus 1,200, so Y is 600. What is the max area that he can enclose? Just multiply those. It's 18, commas in the place, 0, 0, 0, 0, yards squared. That's yards. That's yards. Okay. Whew, that was crazy. All right. Let's take a look at number 11. Here's my graph. No shown with no hidden behavior. That means nothing's happening that you can't see. Okay. Whoa. What happened? Oh, weird. All right. This is the graph of H prime. That's important. So let me make a sine line graph for H prime. It hits at negative 3, negative 1, and 3. And you guys, it's above the axis, below the axis, below the axis, above the axis. So where is it decreasing? It's going to be decreasing right here. Negative 3 to 3. So I'm going to say it's decreasing on negative 3 to 3 because f prime is negative, right? So we got to make sure that we write our justifications on here. Where does it have a relative min? Okay, if I go back here and I kind of draw this in, it goes increasing, decreasing, increasing. It has a relative min at x equals 3 because f prime changes negative to positive. Okay? Now we're going to go ahead and make a sine line graph for the second derivative. And you guys, the second derivative, we're looking at where is the slope of the derivative 0. Well, I have this. Something is going on there. It's not 0, but it's changing slopes. I've got negative 1. And then from 0 to 2, that's all 0. So I don't know. Maybe I'm just going to put like a 0 like that. Okay, one second. Okay. Oh, I was in here. I was saying like this, sort of all the way across is 0. And so what's happening here is these are all negative slopes. These are positive slopes. These are negative slopes. That's a 0 slope. And then those are positive slopes. But what that means is that like 0 and 2, for example, are not points of inflection because they change from negative to 0 or 0 to positive. Then they have to change from negative to positive to be a point of inflection. Okay? All right, I'm going to write part C over here. This is for part C. Where is H concave up? H is concave up on the intervals. That's going to be here and here. -2 to -1. 2 to infinity, because now normally I would want to say H double prime is positive, but I'm not allowed to say that, remember? I can't say anything about H double prime. I have to talk about what was given to me, which is H prime. So I switch that. And what means H double prime is positive? H prime is increasing. That's what that means. Okay, so that was part C. All right, part D. Where do we have a point of inflection? Only at -2 and -1. Because H prime is changing from positive to negative or negative to positive, right? But I'm not allowed to write H double prime is changing positive to negative. I have to write something about H prime. So I'm going to say H prime is changing from increasing to decreasing and vice versa. Okay? All right. E, let's go ahead and put that down here. Increasing and concave down. Well, I'm going to leave this part blank for just a second because I'm going to say H is increasing where H prime is positive. And then H is concave down when H double prime is positive, which means H prime is decreasing. So I'm looking for a place where it's positive. Now look, there's not too many choices for that. It's positive and decreasing. And it's only going to be that side. So it's -infinity to -3. Because, oops, I was going to write it there. That is where H prime is positive and H prime is decreasing, which says H is increasing and H is concave down. It's crazy. All right, hopefully you guys are understanding this. These are tough. Okay, let's look at F. Decreasing and linear. So blank because H prime is negative and there's no concavity. So how could we say that? H prime is horizontal because I had a horizontal slope. So it's basically between here and here from 0 to 2 because I have a horizontal slope right there. So decreasing and linear. Okay. All right. Now, a lot of times, especially on like an FRQ, it'll have you do all that stuff and then it'll give you a couple of like problems to do, right? Okay, so check it out. If f of x is 3 and then h prime squared plus 4x the third, find f prime of -2.5. Okay, you guys check it out. Take the derivative. That's going to be 6 h prime of x to the first times the derivative of the inside. And for chain rule on this, you guys, the derivative of the inside is h double prime. Now, I'm going to erase that because that looked like a prime that was just to the first. Okay? And then this is going to be 12x squared. So f prime of, what am I finding this of? -2.5 is 6. And then it's h prime of -2.5. And then it's h double prime of -2.5. And then it's 12 times -2.5 squared. So what I need to find is what h prime is and what h double prime is of -2.5. So let me go up to my graph up here. -2.5. Let me erase some of this stuff. All right. Kind of hard to tell. I'm not just going to guess though, okay? This is -3, 0. This is -2, -3. So where's negative 2.5? Well, it's this is linear, so it's halfway between 0 and negative 3, so that's negative 1.5. That's h prime, because that's the actual value of it. Now look, h double prime means the slope. What's the slope of this? Well, the slope at that point is down 3 over 1. Okay, so negative 1.5. So that's negative 1.5. The slope is negative 3. And this is an FRQ, so we honestly could just leave it like that. Okay, if you really wanted to plug it in, you could. You get something, but you don't need to. It's an FRQ. All right, last one on this problem. Okay, h, find the limit as x approaches negative 3. Well, at negative 3, h prime, kind of erase some of this stuff. At negative 3, h prime is 0. And then negative 3 squared minus 9 is 0. Now, this is how I talked to you guys about this on the last test. This is how I want you to write it, okay? I want you to say the limit as x approaches negative 3, h prime equals 0. The limit as x approaches negative 3, x squared minus 9 is 0. And then just say by L'Hopital. And then we're going to do the actual problem. Okay? So then we're going to do, all right, the limit as x approaches negative 3 of h double prime, and then on the bottom is 2x. Now, h double prime of negative 3 means the slope of this graph at negative 3. And that slope was down 3 over 1. So that was negative 3 over negative 6, or that would just equal 1/2. Okay. Ooh, sorry about all that messy writing on that one. But that was like a really, really good review question. Hopefully you guys are able to follow along. Okay. Number 12 is the second derivative test for critical numbers. X equals 3 is a critical number, but the second derivative is less than 0. That means it's concave down. So it's a critical number, but it's concave down. Does it have a local max, min, or neither? This has a local max at x equals 3 by the second derivative test. Okay. Let's see if I can fit 13 over here. What is the maximum height reached by a ball thrown upward if the ball's height is given by this position equation? Do not use a calculator. We know that to maximize things, we just take the derivative, set it equal to 0, and solve it. Okay, so at time 2, and if I plug that in, 2 squared is 4 times 16, that's negative 64, plus 128 plus 6, so that's 70. So this would be at time 2 seconds. What's the maximum height? The height is 70 feet. Okay. All right, nice. Okay. Let's do 14 over here. Find a, b, and c for f of x is ax squared plus bx plus c, such that, okay, I have this, and then f has a min at that. That tells me two things. Actually, when it tells me what a relative min is, it tells me two things. It tells me, number one, the point negative 1, 2 is on the graph of f. It tells me, number two, that the point negative 1, 0 is on the graph of f prime, because when I'm taking the derivative and setting it with 0, that's what makes it a critical point in the first place.